The Mercedes-Benz handheld tester is a major advancement in the area of performing diagnosis. It's capable of performing an impressive number of diagnostic functions in the major systems of the vehicle. The objective of this program is to introduce you to the operation of the tester. Before we get into actually operating the tester, let's get a few of the key service points and do's and don'ts out of the way. From the service standpoint, under this cover, you'll find that the tester is fused. You should also know that there are two very expensive mistakes that can be made when connecting and disconnecting the tester. First, the ignition must always be off. Second, there's a sequence that must be followed when connecting or disconnecting. When you connect the tester cable to the vehicle, the cable is hot. There's voltage applied to it. If you should touch the other end to ground or misalign it when trying to connect it to the tester, there's a very good chance of damage. So you should always have the cable connected to the tester first, and then connect and disconnect at the vehicle. In addition to these cautions, there are others that you should be aware of. So before you use the tester for the first time, review the important notes found at the front of the tester operating instructions. Now, let's look at the concept of performing testing with the HHT. Two components are required to proceed with the testing: the tester module and the tester test manual. The module is the software that contains the test program, and this is the brains of the tester. It's updated on an ongoing basis as the test program is improved and expanded, and identified by a month and a year, found here. When a new module is released, a new test manual that corresponds to the module is sent with it. The test manual is also dated to identify the module that it applies to. It's important to understand how the test manual is used. The first 6 or 8 pages in the manual cover key points that relate to using the tester. You should review these pages before using the tester for the first time. The primary purpose of the test manual, though, is to provide supporting information that is not displayed on the tester. Using the manual will be covered during the testing that we're going to do. To get started, the first thing necessary is to select the correct adapter cable. There are 3 cables supplied with the tester. If the vehicle is like this 300E, with a rectangular diagnostic plug, this cable with the individual leads is used. You'll see the use of the other 2 cables later. Now remember what was said about connecting the tester. Key off. Connect the cable to the tester first and then to the vehicle. Connecting this harness to the vehicle is basically the same as connecting an impulse counter. Red to B+, black to ground at socket 1, and yellow is the signal lead which is connected to the socket for the system being tested. The tester will show you where to connect it. The harness has one additional lead that the impulse counter doesn't have, which is this white lead used to pick up circuit 15, the circuit energized when the key is on. Circuit 15 will normally be found here at socket 16. But if you encounter one of the few early '93 models, like this one, socket 16 may be blank. In that case, you can use an extension wire and connect the white lead to circuit 15 at this terminal on the left fender. The tester makes it pretty difficult to make a mistake. As you can see, the display is telling us that the module is missing. So I'll plug the module in. It'll only go in one way. When the module is loaded, the display changes to this screen. The vehicle types that this module applies to are displayed. In this case, the 124, the 124 4 and 5 liter, 129, 140, and the 201. Okay, the operation of the tester actually begins with this symbol at the bottom center. Any symbols found here identify the tester keys that are active. And if you push an active key, a command is entered. At this point, only the Enter symbol is shown, and that will bring up the first menu. Now, think of a menu as a table of contents at the front of a shop manual. It's used to allow you to go directly to the chapter that you want. This first menu is titled Model. You use this menu to enter the model that you're testing. That's done by moving the cursor to the correct line. The cursor is moved up or down with these two keys that are now active. The down arrow moves the cursor down. The up arrow moves it up. When the cursor is at the line you want, the Enter key is used to advance to the next page. Incidentally, we selected the line we wanted by moving the cursor, but the selection can also be made by pushing the number key that corresponds to the number on the display. When you push the number key, the next page comes up immediately without having to use the Enter button. For example, if you were testing a model 129, which is number 3 on the menu, you would push number 3. As you can see, the next page displayed is the menu for a model 129. Of course, we're on the wrong menu to continue testing with this 124 model, so now we have to return to the previous menu. That involves another key that is active now. This double arrow, called the return command, always returns you to the last menu that was displayed. So the return key is used to return to the menu. Model 124 is selected, and the Enter key advances the tester to the next page. A menu is displayed titled Systems, Engine 124. This menu lists 4 systems found on engines that are installed in a Model 124. Now, if an abbreviation shown here isn't familiar, you would have to identify it before continuing. This brings up a new command key that's now active. This question mark means that the help key is active. Whenever this key is active, you can access additional information that isn't presently shown on the screen. So let's see what it will tell us. This help page identifies abbreviation codes. For example, EDS was one of the codes on our screen, and that's the electronic diesel system. That wouldn't apply to this gasoline model that we're testing, and the other codes that were on the menu aren't shown on this page. So that brings up a new command key that's active. This key is the scroll key, and it's used to turn to the next page when more than one page is needed to fit all of the information. The next page has the code for the diagnostic module, which was one that was on our menu. And the next page has the code for the hot film injection and ignition system. That's the system we want to use to demonstrate the tester. If you want to turn pages backwards, the backward scroll key will do that one page at a time. But we want to return directly to the menu to continue with the test, so the return key is used. The hot film system is line 1, so the number 1 key is pushed to continue. The next page tells us to connect the tester signal wire to socket 8. The next page tells us to switch the ignition on. When communication is made, the next page automatically comes up, which is the Functions menu. There are 5 selections on this menu, the first being Control Module Version. Entering that selection turns to a page that identifies the HFM control module installed in this particular car, along with some detailed information about that control module. This information would be useful, for example, if you received a service information that referred to a certain series control module and you needed to identify the one installed in the vehicle you're testing. Returning to the function screen, the next item on the menu is Diagnostic Trouble Code Memory. The next page provides the choice of reading faults that are currently present in the system or faults stored in memory. For example, a fault that is currently present in the HFM system on this car is engine coolant temperature sensor. Now let's look at other information included on this page. On the left, the familiar fault code as seen on an impulse counter, which, by the way, is now called a Diagnostic Trouble Code, or DTC. And the component is listed next to the code, the engine coolant temperature B11/3. But in addition, there's an unfamiliar symbol. The help key is active, so let's use it to see if there's information about the unfamiliar symbol. We find that the help page explains that the various symbols indicate the nature of the problem. This symbol indicates that the problem is a short circuit. This symbol indicates, more specifically, a short circuit to ground. This symbol, a short circuit to positive. And this symbol indicates an open circuit, which is the problem symbol shown on our screen. One of the reasons for the test manual applies now, so let's take a look at the manual and see what it does for us. When you know the trouble codes that are present, the next question generally is, where do I look in the diagnostic manuals to find the circuit testing needed to pinpoint the problem? Let's go through one quick example of how the test manual is used to help you do that. The tester reads a trouble code 3 in the hot film system, the coolant temperature sensor. And further, it identified that the cause is an open circuit. But the tester didn't tell you exactly where the open circuit is. You still may have to hook up the socket box to locate the exact location of the problem. Well, so now you're faced with a literature search. You need to know which diagnostic manual covers the system, then where in that manual to begin. Here's how the test manual is used to save you time with the literature search. It's divided into sections by system. So in this case, you would look for the HFM section. Then you would find the fault code, in our example, code 3, for the coolant temperature sensor. Then, in the extreme right column, you will find the diagnostic manual needed. In this case, Engines, Volume 2. Index 1.1, which is HFM sequential fuel injection. Section 23, which is the testing section. And finally, Test Step 8.0, which is the exact socket box test required to pinpoint the open circuit. As you can see, spending a minute in the test book can save you several minutes searching the diagnostic manuals. So now that we understand one of the applications of the test book, let's return to the tester. Returning to the function menu, the next choice is titled Actual Values. This choice will be available on the next hookup we want to demonstrate. So let's end the testing on this 300E and go to a car with the round diagnostic socket. If you're working with a vehicle with a round diagnostic socket, such as this 300 SE, then the cable with this large housing is used to connect the tester. This housing contains electronics called a multiplexer. The multiplexer is an electronic switch that automatically selects the vehicle systems and makes the necessary connections for the tester. Because of the electronics in this housing, you want to handle this cable carefully, especially when connecting and disconnecting. Remember, key off and connect the cable to the tester first, vehicle last. The last cable is simply an extension cable, which allows closing the hood so the car can be driven with the multiplexer cable connected. We'll use the extension so you can see the complete connection procedure. Let's hook up the tester to this 300 SE and go through some of the tests. First, the multiplexer cable is connected to the tester. Then the extension is connected to the multiplexer. And the last connection is made at the diagnostic plug. We advance to the first menu and select Model 140. The next menu, titled Main Function Groups, begins with a quick test. The quick test checks for diagnostic trouble codes in the 4 major areas of the vehicle. These 4 areas include all of the individual vehicle systems that the tester is programmed to test. The next page states that you should turn on the ignition. Following that, you'll see a note about a stationary heater. That is an option that doesn't apply to US vehicles. So the quick test begins when you access the next page. As the quick test is in progress, you'll hear fans running and relays operating. The warning lamps on the dash will go on and off, and so forth. That's normal, since the multiplexer is actually operating the systems. As the quick test for each of the major areas of the vehicle is completed, you'll see a check mark displayed if everything is okay, or an F if there are faults in that area. Quick test results is a choice displayed at the conclusion of the quick test, and that page will show you all systems that have faults. Each system with faults can then be accessed individually. Let's access the LH injection system. The faults are the engine coolant temperature sensor, circuit 2, and the engine coolant temperature sensor, circuit 1. That would agree with the problem that we simulated by disconnecting the engine temperature sensor. After completing the quick test, we went directly to quick test results for a readout of all faults in all vehicle systems. But there is another path that you can take with the tester that will provide additional and more detailed testing. To follow that testing path, at the conclusion of the quick test, you select the individual area with faults. So we'll move the cursor to Engine and enter. On this page, all 8 engine systems that may be involved are listed. So let's proceed by accessing LH injection, and the next page displayed is the Functions menu. The LH Functions menu lists 5 choices. The first 2 are Control Unit Version and Fault Memory. These 2 pages are basically the same as on the 300E seen previously. So let's go directly to the first Actual Values page, since we haven't seen this yet. Actual values on this 300 SE presently checks approximately 30 separate items associated with LH injection. The values shown on the tester screen are actual operating values related to these 30 items at this moment in time. Let's review a few lines so you can see how these pages can be used for diagnosis. The first value shown is engine speed. And here, the tester would function as a tachometer to show RPM. The second value is the coolant temperature. Both of the sensor circuits are displayed, which allows a comparison to be made. For diagnostic purposes, you would expect the temperature displayed for both circuits to agree with what a logical value should be, and the two values should obviously be pretty close together. As you can see, a minus 59 degrees C is shown for both circuits. That's obviously a wrong value for a warm engine, but the value confirms the problem that was simulated by disconnecting the sensor plug. Let's use this simulated problem to demonstrate how an actual values readout can be used to expand on a diagnosis. If there was a real problem with the sensor connected normally, it could be unplugged, the circuit bridged, and the value checked again. The value for circuit is changed from a minus 59 degrees to a plus 300. So it would be a pretty safe assumption that the circuit is okay and the sensor is open. A more accurate test can be done by using the decade box. By inserting the specified resistance into the sensor circuit, an exact temperature can be simulated, which should then be read by the tester. So in this example, being a little creative with the handheld tester made it unnecessary to hook up a socket box to confirm the problem. Returning to the actual values page, the third readout is on-off ratio. So let's start the engine, warm it up, and read this value. As you can see, the on-off ratio is fluctuating around 50%. Here's an instance where you may have the question, is this a correct value? Here's how you would use the tester test manual to determine that. You'll notice that each readout is identified by a number. This number is called the actual value display number. For the on-off ratio, it's 0, 3. Don't confuse this number with the diagnostic trouble code. There's no relationship. Looking in the LH section of the tester test manual, the second column is titled Actual Value Number. The display numbers aren't in sequence, so you scan this column until you find 03, which is the on-off ratio. The third column describes the test condition, which must agree with the test as performed. During the test just performed, the vehicle was at idle with an engine temperature above 70 C. So the on-off ratio should have been 50, plus or minus 10, and the readout should oscillate, which is just what we saw. It would take a lot of time to review all actual value readouts in LH injection, and that's not necessary anyway. The concept of using the display number to find supporting information remains the same for everything. So let's go back to the Functions menu and see what else is available. Activations is the next choice. Activations allows you to use the tester to operate some of the components in the system that's being tested. In the LH injection test program, the air injection system can be turned on. The EGR can be turned on. The camshaft timers can be actuated. The injection valves can be turned off, one at a time, with the engine running. The purge valve can be opened and closed. And the hot wire burn-off can be operated. We'll operate the air injection to demonstrate one complete activation test. First, the ignition must be turned on, and only when instructed to do so, we'll start the engine. The present engine temperature is shown, and the instructions are that the temperature must be more than 70 degrees to continue. The tester actually locks up and won't let you go further until that temperature is reached. After reaching temperature and advancing to the next page, the tester tells us that lambda must be operating before we can continue. The next page gives the test conditions and desired results, which are: the engine must be idling, the air pump will engage for 5 seconds, and the result should be that the O2 sensor voltage drops below 80 millivolts while the air pump is on. As you can see, the oxygen sensor is being used to check if air injection is working. The next page is used to actually perform the test. The air pump is presently off, lambda is operating, the oxygen sensor is oscillating over a wide range, and the instructions state, with the pump on, does the oxygen sensor voltage drop below 80 millivolts? Now the function keys come into play for the first time. Commands can also be entered by pressing the function key directly under the choices displayed on the screen. So the F2 key will be used to start the test. Okay, let's initiate the test. The start button is pushed, and the oxygen sensor voltage does drop below 80 millivolts for 5 seconds. So we know that the air injection system operates normally. But let's assume that the test failed. The millivolt reading did not fall below 80. The No function key accesses a page that lists the possible causes. The possible causes are basically everything involved with the air injection system, so this screen isn't a big help. But since you're able to use the tester to force air injection to operate, a little knowledge of the system will take you a lot further in making a diagnosis. For example, check to see if the air pump clutch engages when you force the system to operate. If it doesn't, then the clutch or its control circuit are suspect. But if the clutch does engage, your search is narrowed to finding out why the air didn't arrive in the exhaust system. The other systems that can be operated by the tester would be diagnosed in the same way, by observing the results and applying your knowledge of the system being tested. We've only covered testing a few systems using the handheld tester. There are several other systems and other capabilities of the tester that weren't even mentioned. Also, keep in mind that what you saw here applies to this module, and that will change as the test program is improved and expanded. But this program is only intended to present the concept of using the tester and provide the basic operating knowledge necessary to get you started. As you can see, once you understand the use of the different command keys, the tester walks you through each test. There's one final important point to be made, though. The potential of the handheld tester is still determined by the knowledge of the user. Although the tester will make every technician a better diagnostician, the technicians who understand the operating theory behind the vehicle systems will be the most successful using the handheld tester.